Assalamualaikum warahmatullahi wabarakatuh. Today we are going to do the site visit presentation based on our site visit at Proton casting plant for the subject of MEC 640. My name is Muhammad Shafiq bin JOHARI, and here are our group members of Muhammad YUSHAIMAN HABIB bin Muhammad YUSOFF, Muhammad IKRAM bin Muhammad PADHLI, Muhammad ZUHRI bin Muhammad GHANI, and Ahmad Amirul bin Ahmad Shukri. And I will now begin with the introduction section. The background for the proton casting plant. The proton casting specializes in the production of cast iron products. The company manufactures the casting parts of engine for proton cars. This company is a department of the Proton company, which started operation in 1994 and which was officiated by the Prime Minister on 18th of March 1995. This company is certified ISO 9001 and 2000, and it has been certified since December 1997. It is the only manufacturer of Proton's Campro cylinder block and crankshaft castings. The company workers in this plant work in 2 shifts of morning and night shifts. The company have the target units of 300 units of cylinder blocks as their target for each shift. This company manufactures engine parts that are big and small. The big parts consist of the cylinder blocks, and the smaller parts that consist of the crankshaft and bearing caps.
Okay, my name is Ahmad bin Ahmad Shukri. Now I want to discuss about casting process flow. Before the casting work is done, the mold must be prepared first. The mold preparation process includes sand treatment and co-making. Next, the process of melting, pouring, finishing, pelletizing, and delivery can be done. Okay, next for the molding process flow. For the core making, a core is a material used in the molding process to create a cavity in a product. A core is usually unusable and burns during the process of pouring the molten metal in the mold. And for sand treatment, is carried out in a highly controlled manner in a specialized furnace to ensure that the casting retains its original shape without cracking. And the last one for molding process. Molding is a manufacturing process by forming raw materials using a frame, or we call flux, and a master pattern called a mold. Core making. There are 3 main core products that are used to create the cylinder block at Proton casting plant, which is jet core, oil drop, and crankcase core. For oil drop, it have 2 types, which is oil drop exhaust and oil drop intake. This is core making flow process. Each of process I will explain in next slide. For the first process is core sand. The method of core molding is distinct from the process of preparing core at the center of the mold. This procedure explains what core sand is and forming the main method. A casting may require the use of a core, which is an insert made of sand that is utilized to mold any section of the casting that cannot be molded by the primary removal pattern. It is possible to create a concave impression in sand by first pressing a pattern into the material and then removing it. This void is filled with liquid metal, which is the cools, or we call the cools. The creation of core makes it possible to incorporate a greater level of complexity into the design. Okay, for core molding, in proton plant casting we use method shell molding. In this method, the core sand is produced by adding additive, for example resin, urotropin, and etc. into the silica sand. Silica sand is filled by using a pressure into a mold that has been heated at a temperature of around 250 degrees Celsius to 300 degrees Celsius during baking. Okay, for core finishing, During the process of separating the molds from one another, an excess edge of the core, also known as the parting lines, is created. Consequently, this may result in imperfection on the surface of the core. During the operation, faults will be fixed and extra material will be removed from the core edge. Okay, next, core coating. Sand form core having a higher chance of having imperfection. This procedure either shield the sand core from faults such as liquid metal penetration or prevent defects such as liquid metal penetration. Okay, for the next process, core drying. Core that are dyed and coated will contain a certain amount of water. The core without the drying process will be one of the main reasons defect with respect to gas, because the drying process is important. The type of core drying such as furnace using gas and electric heat. Okay, for the last process is core assembly. The adhesive is used to adhere the core assembly that is put in place following core process. The removal of the core result in the dimension product not being up to the requirement setup. Okay, for the second process, which is sand treatment process. Sand treatment process is use the sand that have been used by adding the green sand mold. The process of adding green sand composite is based on the percentage of the green sand composite remaining after the molding casting process. Below are the percentage of green sand composite: silica sand, bentonite 5 to 11%, water 2 to 4%, and cornstarch, fall clay, panther, sea coal, dust with 0 to 1%.
Hello, Assalamualaikum. My name is YUSHAIMAN HABIB by MUHAMMAD YUSOFF, and I would like to present about the molding flow process of the proton plane casting component. Now we go to the molding process flow using APK machine. Create a mold, cope and drag, roll over, sand cutter, groove cutter, sprue cutter, pierce hole, chamfer cutter, flush transfer, inspection and cost setting, flush closing. Now we go for the create a mold. To create a mold, it will start to spray a separating agent to the mold to prevent sand from sticking to the master pattern. The master pattern is placed on the upper and lower mold box, which is cope and drag. Next, fill the sand in the mold box and compress until the sand is completely compact. Next, remove the master pattern. This process will take time for 40 seconds. Next, we go to the cope and drag, roll over. The upper and lower mold box, cope and drag are rotated. Mold surface on the top. This process will take time in 40 seconds. Then we go for the sand cutter. It will trim and discard excess sand on the surface of the upper mold box. This process will take time in 20 seconds. For the groove cutter, the machine make a groove around the upper part of the mold box. It will avoid pouring overflow up to the mold box. This process will take time in 20 seconds. Next, for the sprue cutter, the machine will make a sprue cap at the inlet on the upper mold box. This process will take time in 20 seconds. For the pierce hole, the machine create a hole in the upper mold box for the gas production during pouring. For the chamfer cutter, the machine will create an oblique angle on the pouring cup. It will prevent mold sand erosion during casting. It will control and smoothing the casting flow. It will produce laminar flow in the casting. This process will take time in 20 seconds. Now we go to the flux transfer. The flux transfer is to transfer of the moldboards to the next section using a lifter. This process will take time in 20 seconds. For the inspection and core setting. First, for the inspection setting, the machine will measure the hardness of the mold sand. It will clean the sand mold from foreign matter. The machine will place the core in the sand mold cavity, which is oil drop. This process will take time in 40 seconds. Second, for the core setting. For the core setting, the machine places the crankcase on the jig, water jacket, oil drop exhaust and filter strainer. It also could clean the debris on the core. When the mold are ready cooked, it will ready to be transferred into the sand mold board. This process will take time in 40 seconds. Last but not least, the process in APK machine is flux closing. This process is joining the upper and lower mold boards before go to the pouring process. This process will take time in 40 seconds. Now we will go for the melting process for the next step in casting.
Now we move on to the melting process. Metal must be properly melted before being poured into a mold. Melting process is the process of preparing the molten metal to be used for casting process. On our site visit at Proton Casting, we have found out that the maximum amount is 8 tons of molten metal per batch. The metal materials that is being melted and turned into molten metal is called a bale. Once properly prepared through the melting process, we can now use this molten metal for the casting process. Now on this next slide, we can see the melting process flow in Proton casting plant. Now we can see in the startup furnace section that the starting block is 4 tons, the steel scrap is also 4 tons, and the amount of carbon and silicon carbide that is being placed inside the batch of molten metal. We can also see that the chemical composition section, that the temperature of this process is 1350 degrees Celsius. Now in order to adjust the chemical composition, we also have the ranges of percentage of the materials in the molten metal. And now we move on to the next slide, in which we have a picture of the furnace, and we have the diagram of the furnace and the components of the furnace. That is all for the melting process.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is IKRAM bin PADHLI. So I'm gonna present about the pouring process and the finishing process.
For the next process is pouring process. Basically, the molten metal will be poured into the ladle with a minimum temperature is 1420 Celsius. Then, the molten metal will be transferred to the mold. We were unlucky because at that time, we could not see this process because the metal was not cooked completely due to the wine not being enough to burn the metal. After that, the mold will be cooled in 18 minutes. After that, the worker will remove excess metal due to pouring step, and the excess metal will burn again to make another product. Lastly, the sand will be isolated from the cylinder block. The cylinder block will be cooled again in 2 hours, then sent to finishing process, while sand will be sent back to sand preparation tower to be used as a green sand. Next is a finishing process, which this process is very important to make sure the product in a good condition and not give harm to the user. So, first step in the finishing process is the worker will remove the reback as the cylinder block was come with reback. Then, the cylinder block will be through the shot blasting room to make sure the surface not rough. The bullet that used is carbon steel that shown in the second picture of the shot blasting. Lastly, the cylinder block will be painted to prevent rust. As you can see, the first picture shows the product after shot blasting process, the second one in a painting process, and then the last one is the finished product.
My name is ZUHRI. I will cover for the next process, which is pelletizing. So when the cylinder block finish the final process, it will be stacked on an empty pellet. There will be 10 pieces of cylinder block in each pellet. And then the final of the cylinder block at this factory is delivery. So every pellet with 10 pieces of cylinder block will be tagged with an ID. Then it will be lifted up with a forklift into the delivery transport to be transported to the next plant, which is engine and transmission plant. Next is manufacturing process and technology that was applied in this factory. Most of the machines that have been used at the plant casting is for third industrial revolution, which computer replace human as mean of control, which is APK machine, shear molding, unloading machine, shoot blasting, painting machine, drying oven, water jet blasting, sand ramming, forklift, in-gauge cutting, shape shaker, auto pouring machine, crucible furnace, reverberatory furnace.
Now I will be presenting for the defects. First, we can see that this is the result of a core defect. These cores are defective because they collapse and they lost shape after the core making process. Cores are very crucial in shaping the interior dimension of a finished product. Therefore, their shape must be precise. Now, since they no longer have their shape, they can no longer be used for casting process. However, these defective cores will not be thrown away, but they will be recycled, in which the sand will be used to make new cores. Secondly, we have the block defect, and in this case, the defect that we have is because of an irregular crack in the engine block, which makes it unusable. This defect is known as rat tails or veins. This defect occurs when the surface of the molding sand buckles up during the casting process. This defect can also occur when excessive heat of the metal causes the expansion of sand. This defect generally happens on the bottom surface of the mold. In order to prevent this defect, the pouring temperature must be slightly reduced. Next, we move on to the defect of shrinkage. Shrinkage occurs during the solidification process. This defect happens when the feed metal that is available is insufficient to compensate for the shrinkage that occurs during the solidification process. This type of defect will reduce the structural strength of the product. Now, in order to prevent this defect, we can also reduce the casting temperature to limit the total volume deficit. Next, we move on to the defect of hot tear. Now, these crankshafts in the picture are considered defects because they have a fault that is called hot tear. Hot tear is when a discontinuity occurs during the solidification phase of the casting process. During contraction, any force of restraint will impede the contraction process, which will cause the issue of hot tear. Now, if a product has hot tear defect, it will make the product more vulnerable to corrosion and to failure. And that is all for the defect
So back with me, ZUHRI. We had a meeting with the supervisor that accompanied us until the end of our visitation. Also, we had an online meeting to complete the task given to us. For discussion, we have two into our consideration, which is about safety and hygiene. In our observation, the safety in the casting plant need to be taken more seriously, which is needed for the worker to wear an earplug to protect the ears. Second, worker at melting process also need to wear a safety suit to avoid harm of the splash from the molten metal. In terms of hygiene, the worker must have responsibility to not throwing any rubbish into the defect product bin. Mix the rubbish with defect product will be make other worker difficult to separate the rubbish and the defect product to be used again. That's all for our site visit presentation. Thank you.